Good morning, good afternoon, good evening, and welcome to another episode.
Working on OpenShift
And sometimes
we have a
This is so awesome.
are an open culture that believes
It's actually
in
a big
importance of
piece of the component for your GitOps work.
Everybody has something that they can say.
On top of the Red Hat portfolio.
Wow. That every time that that opening at this point is just nostalgic.
right?
Right? Like there's
Memory
Chris
lane.
Short, Christian Hernandez, like who else isn't even here anymore? Is Landon still here? Landon left, right?
I don't know.
Yeah, man, it's nostalgic. Anyway, hello, GitOpsians. Welcome to our special time edition of GitOps Guide to the Galaxy. And actually, this is kind of great. I think we should do this again, except for, you know, with a little bit better coordination on your end and my end, Johnny. we did never have our stuff as together as we tell ourselves we will. Anyway, quick announcements. What quick announcements? I don't have any. KubeCon is coming up in a few days, and I will be there, and Johnny will be there, and our guest Priyanka Saggu will be there. And speaking of traitors, Priyanka and I met when she and I started Red Hat on the same day, on the same team. And then she left and I didn't. So, you know, shame. Yep. Anyway, but since Priyanka has left us, while she was at Red Hat, she did really cool things. Since she's left us, she's done really cool things. But of all the cool things she does, the thing I've been watching the most closely has been her involvement with the Kubernetes community. Whoa! I get like slapstick silly late at night, folks. Like this is just life. Craig says Craig was my first manager and Priyanka's first manager. So that's hi, Craig. Anyway, so let Priyanka actually introduce herself now that I've publicly shamed her and this will be memorialized on memorialized, something like that. One of those things on the internet for forever, which is great. Priyanka, please tell the GitOpsians all about yourself.
Hey everyone, and thank you, Hill, for that great introduction. I like that part. So if it's going to be there on the internet forever, I think that's a great thing. Hello everyone, my name is Priyanka Saggu. Currently, I work at SUSE as a Kubernetes integration engineer in the business critical Linux department. And I do serve a few roles in the upstream Kubernetes community. Currently, I'm a technical lead for special interest group contributor experience, a GitHub admin, and a new membership coordinator, as well as I'm privileged to be the release lead for Kubernetes 1.29 release cycle, which is I'm helping to coordinate a team of 40 amazing people across 7 sub-teams to bring in a new version of Kubernetes to life.
40.
Yeah, 40 is what we have on the team, and I would say it's the whole community because it's not just the release team.
Right.
Actually,
but just the release. There's a degree to which I pay attention and know these things because I'm on the code of conduct committee for the Kubernetes community. But like, I never actually sat there and counted and realized that the release team's like 40 people.
Yeah, 40 with a few titles as leads and shadows and lead shadows and emeritus advisor. What I would say is those are the people just shepherding stuff. Most work actually happens by the community, so it's thousands of people actually involved in a single release. In that small group of release team folks, we just somehow managed to shepherd and bring it all together in different release cuts.
And there's a lot of pieces, right? You've got the docs things that have to be coordinated. I mean, it's not just about the actual code and PRs and stuff itself. Like there's a lot that goes into a release.
Yeah, the work actually is divided into 7 sub-teams. It starts with enhancements, which is the team that's responsible for collecting all the features or deprecations or removals or anything that's going to be a major change involved in a release cycle. Uh, that's the work of enhancements team to collect all those from the community, and that happens as the very first thing in a release cycle. After that, we have a milestone called enhancements freeze, and that's time when uh, we have an idea of what is going to be there in the release, more or less. After that, yes, we have docs coming in on whatever that's already included. We start to collect docs about them and release notes, and there is a comms team that does all the communication but on what's happening, what's going to happen, what's going to be the outcome of this release, what are going to be the major changes, and all those major communications happens through the comms team. And there is a CI signal team that's very much relevant to the topic of what we are going to discuss today, which keeps a track of our CI jobs to make sure everything is healthy on the Kubernetes master and all other things that are responsible for a healthy release. Yeah, and same is for bug triage. There is a team that's responsible for triaging all the bugs that we are receiving throughout the cycle of release. Yeah, I think I did not miss. So we have 7 or more.
Wow.
Yeah,
Is that
And
all? Nothing
there is a
else?
branch management,
the branch
which actually
management.
tracks the releases.
So
Oh
like you have to
man.
shadow, right? Before you can go to become a coordinator, you actually have to shadow a release. Is it one release or 2 releases before you can actually become a coordinator for your own, I guess?
Um, I can share about my journey. I started in 1.23 as a enhancement shadow, and it took me, let's say, 6 releases to be a lead, and that's also very much n- dependent on how willing you are to take on lead roles.
Right.
There are a lot of people in the queue who wants to be lead and who wants to be shadow, who wants to maybe do shadow in different roles. So it entirely depends on what you are trying to get out of this release team, different roles you have. Yeah, it takes a few cycles to become a lead of a
Yeah.
role, and then move forward to maybe lead shadows and then the actual release lead.
And
And
that's
then we have
awesome.
EA, which is above all of us. That's mostly a role for somebody who is returning from
Hmm.
a lead role in past releases.
And congratulations, that's awesome. That I mean, that's incredible. I'd listened to a Kubernetes podcast. It was like one of the Craig Boxmans from a million years ago, and they'd brought some coordinators on before, and like they were kind of talking about their experience too. And it's like, man, it sounds like a ton of work. It's like awesome street cred, right? But like at the same time, it's like it's you've got your job, and then you've got your job to get that stuff out the door and make sure that you've got all the cats herded correctly and stuff like that. So that's congratulations, that's awesome.
Yeah, thank you. And I agree with that. It's hard to estimate what's going to be the work um, after you are a lead or lead shadow, maybe even a shadow. I think shadows do the most work, honestly
Hmm.
speaking, in any release cycle. And leads are mostly using their past experience to coordinate them or to help them do whatever work is required in a release cycle. Um, but yeah, it's mostly you getting a role and then you growing into that role as part
Hmm.
of any release cycle. It's hard to estimate what's going to be the requirements of certain role. Yeah.
Yeah. Nice.
And so that does, like you said, it does segue really into like, well, why are we even here? So, uh, since we have like a very different crowd, like this is not our usual viewership crowd, right? The audience is completely different time zone from our usual live viewership. So for those of you who are new here, um, what we've been doing for the last several episodes here on GitOps Guide to the Galaxy is actually doing an overview of like GitOps is usually very focused towards like CD, really looking at the CI side of things and kind of like what that even is and so forth, and then starting to look at like CI CD outside of both in and outside of like the Kubernetes space. So we've talked about like desktop systems and server side applications and like firmware and stuff a couple episodes ago. Then we talked about Cargo, which is a new, new tool in this space. And then today we're gonna look at Prow because Prow's pretty interesting. The only places I like, actually know of Prow being used, although maybe other places use it, is the Kubernetes project itself and OpenShift.
Mm-hmm.
And so this is very topical for me because being that I work on one of the flavors of managed OpenShift, which is the managed OpenShift on Azure offering, right? I'm starting to get more familiar with what Prow is doing for us and how we use it and how we can even use it better than we're using it today. So like I'm very selfish. I pulled in my expert friend to teach me what I need to know to be better at my day job so that I don't have to independently research. And you all get to come along for the ride. So Priyanka, I'm going to hand this over to you now to kind of go ahead and start walking us through what we like the crash course. What do we need to know about Prow?
Yeah, thank you. So before I start, I just want to mention I gave a talk about Prow in the last KubeCon EU, Amsterdam 2023, and I will mostly be using those slides only. So I actually that's a huge slide deck, so I'll be using part of that slide deck for this particular session. But before I start, I'll share a link to that slide deck here for anyone who wants to follow along. What I can give a brief of what's going to be the agenda for this particular session, and maybe we can go from there. I will start just by giving a brief definition or a verbal definition of what Prow actually is. Like it's a CI/CD and what it is. Then what's the architecture of Prow looks like behind the scenes. So we are talking a lot about Prow Kubernetes, what really that Prow upstream Kubernetes tool actually means and what it looks like behind the scenes. When we talk about Prow as a CI/CD tool, we are talking about doing a few jobs or running a few CI stuff. What those CI stuff looks like in context of Prow. What are the different types of um, stuff we can do on Prow, and eventually finishing our talk with how to consume whatever Prow is running on itself through different user interfaces we have right now available to us. And I think just a bit of we are talking about Prow in context of Kubernetes upstream. So where does Kubernetes upstream store all the source code for its Prow infrastructure and all the jobs that actually runs on Prow? That's going to be what that's going to be my agenda for this session. And if there will be more or less of that, that should mostly be covered in that KubeCon talk. And I'm happy to take any more questions later on, maybe here in this session or later on Kubernetes Slack. So starting with that, maybe I'll start by sharing my screen, and Hill or Johnny, you can help me confirm if that's visible. Okay, I can see it on my screen. Can
Yep,
you?
we're good.
Okay. Okay. So what is Prow? Prow is a CI/CD system. It's created by the Kubernetes project, and it's created for the Kubernetes project. Like the first use case for this particular tool was the project itself, the Kubernetes project itself, and the requirement was for Kubernetes project was to have a CI/CD tool that's Kubernetes native, so we can configure our jobs, all our CI/CD requirements in a flavor that's very much understandable by Kubernetes tooling itself, which means simply we are able to write our jobs in YAML format. That was the requirement, and that's how Prow came up in the thing. This is what basically Prow is. If we have to understand what Prow behind the scenes look like when we are talking about Prow as a tool, what really the tool actually is, I will start by talking about what Prow workflow looks like. So I think we can start understanding Prow in terms of how, as an end user, even if I'm a new person for the Kubernetes project, how I interact with Prow or where Prow comes in the picture, because this is something not people use it. People interacting with the Kubernetes project on a daily basis are consuming Prow every single day, but they might not be aware they are using Prow. Um, directly or indirectly. So I will start by sharing how a new contributor or anybody who is just interacting with the Kubernetes project, let's say through a GitHub org, by creating GitHub issues or GitHub PRs on any of the Kubernetes org or subproject org, where does Prow start coming in the picture? So as a user, I start by creating an issue or a PR and on a GitHub repo. For example, I create an issue or a PR on Kubernetes/Kubernetes GitHub repository, and each of those issue creation or PR creation creates a event, a GitHub event, and those events are then sent to something this big box called Prow. If you have to understand this big box, which we are calling right now Prow, the best example is to understand it with Kubernetes itself. Um, in in the Kubernetes space, we have this concept of control plane and worker plane. The same is the concept being used here for Prow. Kubernetes control plane actually contains all the control plane machinery of for Kubernetes. Uh, Whatever makes a Kubernetes cluster is stored inside our Kubernetes control plane, uh, and every workload that we need to be deployed or commissioned on our cluster goes into our workload clusters. Same is the concept for Prow here. Prow has service cluster and build clusters. Service cluster is similar to the control plane of Kubernetes, and build clusters are similar to the worker nodes. But in case of Prow, we are not talking about single machines or single nodes. We are talking about a whole cluster. So a whole cluster we designate as a service cluster, Prow service cluster, and a whole cluster we designate as a build cluster as well. So in this big box we see on the left-hand side, we have a service cluster, which is Prow service cluster, and on the right-hand side, we see multiple build clusters. So it's the same analogy as Kubernetes. This is the Kubernetes control plane and Kubernetes worker plane. Um, yeah. In Prow, the service cluster contains whatever Prow needs uh, to be working as a CI/CD system. So all the components to, let's say, to start receiving all these GitHub events that are coming from not just GitHub, maybe other uh, incoming sources, all those hook receiving components would be there. Uh, Other components that will help Prow to schedule the actual jobs that we are trying to run on Prow. Everything that makes Prow is going to be deployed inside our service cluster, and all the build cluster will then be used for just running our jobs, all the CI jobs. So that's the basic architecture of Prow. Um, so once coming back to our flow, once I have created an issue or I have created a PR and that generated a GitHub event, uh, that's then going to be received by my service cluster, and service cluster will read that as a trigger for creating a Prow job. Uh, and it will first try to, so we are talking about all this service cluster and build cluster as Kubernetes cluster itself. So everything uh, that's going to be scheduled will be scheduled as a job. Uh, I'm assuming here we understand the Kubernetes terms. We are talking about cluster and Kubernetes cluster and Kubernetes pods here. So whenever we are getting events from GitHub side on any issue creation, on any comments, on any PRs, those are going to be received by service cluster, and then service cluster will schedule them on build cluster as a pod. That's what's happening here. Another thing we can do here is whenever we are creating or generating all those triggers, we can also ask Prow to specifically ask it to schedule it on a specific cluster here. For example, here in this particular case, I have added some meta in my GitHub event trigger that please schedule my Prow job, or please schedule whatever I'm trying to ask you to do on build cluster B. So we can do that as well with Prow. Why we would do that? Yes.
I'm sorry, I don't mean to break up your flow. I just have a question. Like,
Yeah.
can you are you actually like like your build cluster A, B, and C, right, and whatever? Those are all pre-built clusters and they exist in your environment. Like, does Prowl have the capability to like actually spin up a cluster? Like
Um,
hey, maybe I want to test with like the new, nightly of like Kubernetes that's coming out. Can I have it spin that new nightly up and then deploy that action on it?
so I will try to understand the question better. You are asking about different clusters that we are talking about. Can we just spin them up uh, in few steps? That's what are you trying to understand? I think I have a link shared for the Proud documentation, and in particular, let me share another link.
Sorry,
So
I
Prow
know I
is a
interrupted your flow,
tool.
but I was like, I saw it and I was like, oh, this
No
is
worries.
awesome.
Yeah. So Prow is a tool. Even right now, it's a work in progress. Most of our Prow deployments, um, let's say an year back, were on GCP, Google Cloud Platform, and we are trying to make the tool more cloud agnostic. So most of the documentation that I'm going to share will be very quick deployments of Prow infrastructure on GCP, but not very quick on other clouds.
Yeah.
But it's not that hard as well. Yes. So the way these clusters are deployed, we have all the configuration for, like, if our use case is to just build up a Prow cluster or Prow this machinery, uh, similar to Kubernetes Upstream, I think we can grab all the files, all the configuration files from what is sitting inside our test infra repo. So Kubernetes have a repository called test infra, and that's basically the infrastructure for their entire test tooling. And Prow is a major part of Kubernetes test infrastructure. Inside, I'll just point to one folder there in Kubernetes test infra, that's config, and that config folder contains everything that we are going to talk about with respect to Kubernetes Prow. So whatever configuration is used for deploying Kubernetes Prow clusters, this service cluster and multiple build cluster Kubernetes is using many build clusters, I believe hundreds of them at this point. And whatever is the applied state of those build clusters would be present in that disinfra/config folder. Um, and also whatever is running on those clusters as well is also available there. So if we have to just replicate exactly what upstream is doing, um, that's the configuration. To get started with having this cluster up and running, I think I pasted a link to getting started document. We just need access to some cloud platform, and we can use the steps listed there. That would be mostly the same thing, just having a cluster up and running and uh, deploy a few YAML files there that makes that cluster a Prow build cluster or Prow service cluster. That's all I think that is.
Awesome. Thank you very much.
Yeah, Johnny, I think I'm not exactly sure on the OpenShift CI side, some of like the particulars, right? But for example, when we're testing OpenShift nightly, we have right the series of jobs that Prow will create a cluster that matches the specifications of the OpenShift nightly configuration, and we have several of them, and it can spin up a new cluster at that time. But sometimes we also do something called, and I don't know if this is in the upstream, to be honest with you, because I don't know a whole lot about like Prow upstream. We also have cluster hibernation for some end-to-end testing, so that we have a cluster that exists and runs that matches like certain like configuration defaults or whatever, and then so it gets woken up and the cluster like is utilized, and then it gets hibernated while it's not being used to basically save money on compute. And I think we put all those things upstream, but I actually have no idea.
Yeah, the hybrid part, that's part of ACM, right? So I mean, like, or multi-cloud, multi-cluster engine, something like that. Or yeah, it's nice.
Yeah, we kind of drank our own champagne on that because we needed it for ourselves. So we built it, and then I think I don't know to what degree we've made that like available for consumption by customers, but like I think I know it's out there to some degree.
Yeah, no, that's awesome.
I'm not aware of this hibernate feature in upstream, but if it's there in OpenShift and if it's in progress for getting upstreaming, I think it's going to save a lot of problem what we have in the upstream space. cost of running
Yeah,
all
I
these
don't know
tests
what
every
they
single day.
I don't know what
Yeah.
they do with it. It also might be AWS specific. Like, oh, I don't know what cloud we did it all in either. So like it might not work for the Kubernetes Prow because it's all GCP specific. That's one of those things where cloud agnostic is the only way.
Yeah,
Yeah, for
I think like this is just stopping from what we were discussing, but upstream project has made some progress of moving their test workloads on AWS build clusters. So we do not have the service cluster machinery, like the actual Prow machinery running on AWS right now, but we have created a few build clusters on AWS and trying to schedule our jobs from um, the service cluster onto those AWS build cluster. Recently, we had a big problem with this never-ending cost generated from running our just the bare minimum tests that requires us to ensure reliability of Kubernetes releases, and that was basically exhausting our entire credit we had from Google. Uh, Amazon graciously stepped in and gave us some more credits, so we are using them now to help make Prow more cloud agnostic, and we have made some progress. I think it was done in past few months only, where we started moving all our community jobs from GCP build clusters to AWS build clusters. So far, that's going good. There are hiccups
There always
that
are.
were expected, yeah, but yeah, there is some work in progress to make Prow more cloud agnostic. Yeah, so just coming back, yeah, we can ask Prow to schedule our workloads on a specific cluster that's actually done through this field called cluster build cluster, and we'll see where this field actually goes in. Um, and what it will do then is just create a pod for that particular task we are trying to uh, make it work on a particular build cluster. Same, we can just ask it to schedule it on different clusters as well. Once the task actually ran inside a pod container, and whatever is generated out of that particular task in terms of artifacts, maybe the logs that are generated, or if we are trying to get maybe some output out of that particular task, we will get it back from that particular build cluster, and that will be sent back to service cluster, and we will be updating the status of whether the task we asked Proud to run, whether it failed, whether it passed, or whatever uh, different artifacts that were generated out of that task run, we will be getting back on GitHub. And there are a lot of components involved in making that happen, and all those components mostly sit inside a service cluster. Um, just one point, how service cluster and build clusters are connected. Uh, the only way is we have a secret inside our service cluster that contains the kubeconfig of these build cluster. So if we have to connect another build cluster, that means we just have to make that secret available for a new build cluster in our service cluster, and service cluster will start understanding there is a new build cluster available for
Got it.
scheduling our Prow jobs.
I
Um, yeah.
was gonna say, oh shit, what was I gonna say? Oh, there, and also there was my work filter didn't kick in because it's late. It's a good thing this is not monitored by the, what is that, federal whatever. Anyway, shoot, dang it, I had a smart question. I don't remember my smart question, but I swear it was a smart question. What were you talking about? You were talking about scheduling clusters, right? Let me work this backwards. It'll come to me once I stop thinking about it. That's just how that always goes. I learned that from Craig, actually, that if you forget what you were going to say, just keep going. Like you didn't stop to try to say something, and it post-processing will make it come back to the surface eventually.
Yeah, and we are going to keep talking about it, so maybe you
Oh,
might
I
ask
remember.
again.
See, there
Oh,
we go.
yeah.
A few episodes back, we were talking about like the overarching, like what is CI and why is it important? I talked about the importance of using your CI systems for artifact collection so that you can have
Mm-hmm.
your artifacts collected and then do things, either like execute logic or even just do comparisons or what have you, do things off of the existence of those artifacts. And the fact that I always used to put my artifact collection back into GitHub when I was, doing CI/CD systems in days gone by. So you're talking about how like, okay, so we get the artifacts and they go back over here, and the service cluster then puts them in Git, and I was like, yes.
Yep.
This is the way.
Okay.
Like, where's my Mandalorian mask? This is the way.
Yeah. In case of upstream Kubernetes, we collect all our artifacts from all these job runs in I think right now cloud buckets. So it would be GCP buckets or Amazon S3 buckets. That's where we are collecting. There is a retention policy for how many artifacts respective to these frequently running jobs we are going to retain for a specific period of time, and then we just dump them. Yeah.
Yep. And that's exactly what I said. You have a retention policy, and then some logic in the CI system does the enforcement of the retention policy at commit time. Like, that is, yes. I'm so happy.
Yeah. And so with this a bit of what Prow actually is and how it starts coming into picture whenever a new contributor or just somebody who is trying to interact with the Kubernetes project through GitHub, how Prow comes in the picture. So I'll just give a brief example of what is happening there. For example, whenever I create a new PR and that PR is containing some changes, that those changes might be on a certain path in my repo, and that maybe like for a project as big as Kubernetes, we not a single group is responsible for the entire code base there. Actually, it's divided across different SIGs, we call them, or special interest group. So every time, let's say, Prow sees that the new PR is making some code changes on a certain path that's coordinated by, let's say, SIG contributs or SIG node or SIG storage, it will also apply a few labels based on those triggers. So that's where even if we are not really seeing Prow directly as a end user, Prow is acting there. Prow is doing its job of doing all that, applying labels or giving you messages like, oh, you are new here, you have not yet signed the CLA, so these are all the steps to sign the CLA, or maybe I need you to apply a new label, for example, just apply a label like kind, what kind of PR this is. Is it a documentation or a feature? So all those friendly prompts, that's where Prow is coming in the picture. Prow is doing all those prompt work. I don't know if anyone is familiar with this one, but very a simple example. We have some /foo commands on Kubernetes GitHub repos, like /cat or /dog, and what it does, it just tries to get a picture of a cat or a dog from internet and just put that there back in our GitHub PRs or issues as a comment. All those stuff are also done by Prow using this different plugin. So every /foo command is a Prow plugin, and that's where even if we are not using Prow for doing this hard work of running, let's say, tests or any sort of building stuff, we are still Prow is still there in the picture for anybody interacting with Kubernetes at this point. Most of the automation that's happening on Kubernetes project right now is done through Prow.
Yeah.
So
Several months ago, every now and again, so we have similar /whatever command logic across so many of our projects here at Red Hat. Every now and again on this, when Christian was still my co-host, we would joke about /cancel. Like, that moment when you're like, oh, I'm gonna do this, oh no, never mind, I don't want to do /cancel, is actually like, some of our projects actually have /cancel. It's like, never mind, I don't want the CI job to run, I realize I messed up, like, undo, stop, hold all the horses. So that's
a
the
useful
commands are
one.
great.
Yeah. So just concluding what Prow jobs are from what we just discussed. These Prow CI jobs are Kubernetes native CI jobs managed by the Prow CI/CD system. So what we mean here is every job that is running on Prow infrastructure, it's a Kubernetes native CI job. That means it runs inside a Kubernetes cluster. It is written as a Kubernetes, any other Kubernetes object. It is deployed inside a Kubernetes pod. That means it has a container image defined for it, or it has its own pod spec. So it's a very Kubernetes native way of defining CI jobs. For Kubernetes project itself, uh, we are using Prow jobs for doing every automation work, for automate our day-to-day testing, for automation of building our release artifacts, for example, to just keep checking whether our KK master branch, KK means Kubernetes/Kubernetes master branch, or any other release branch is healthy. We keep building artifacts from those branches. So that is also being done by Prow. Or deploying code changes anywhere. For example, let's say I have created a PR that updates a Docker file in my repo, and that needs uh, that and that Docker file will then be used to create a new, let's say, image version, and I need to deploy that change somewhere else in my config. So we have Prow jobs doing that post work as well. If we have merged some changes and that needs doing something else in return, all those stuff is also being done by Prow as well. Um, we define our Prow jobs in YAML files, and for Kubernetes context, these Prow jobs are mostly triggered by GitHub events like pull requests, commits, or we also have scheduled runs like cron jobs. Uh, so we define whatever we just discussed, whatever Prow is doing, we define them in 3 types of Prow jobs. And those 3 types are pre-summits, post-summits, and periodics. Pre-summits is it's like a CI check. Pre-summits come in the picture before something uh, is merged in a Kubernetes or in any GitHub repo, for example. These jobs are the most important job, let's say, for any project consuming Prow or any project consuming any CI/CD tool. Um, the intent of these jobs are to test whatever new changes are coming from any new PR. For example, I'm creating a PR on any Kubernetes GitHub repo, and what would be the outcome of merging those changes in the entire code base, whether it will break something or all those changes are going to be okay. All those kind of pre-tests, we run those pre-CI checks in pre-submit jobs. So we have not many because we do not want to block our PRs just in like a queue of these pre-submit jobs. We have um, many, but not like the biggest number of jobs we have are not pre-summits, and not all of them are blocking as well. But pre-summits, we can understand them as any pre-checks that runs on any incoming PRs before they are merged. And in Kubernetes projects specifically, we do not do manual merges. So we need any PR code changes to be passing the required pre-summits to actually trigger the automated merge as well. So pre-summits plays a big role in Kubernetes project. Post-summits are any job that needs to be done after a code is merged. A simple example is if we have made a Docker file change, we need to publish a new image for that, and that new image publishing thing will be done by post-submit jobs, for example, taking in whatever new is added to our Docker files. And periodics are the simple cron jobs, we can understand them as. These are the jobs that we run on a defined interval or a defined cron schedule. And I think periodics are also another very important jobs we have, specifically for release purpose. We have release informing and release blocking jobs, and these are periodic jobs that are running from let's say release branches, pointed at release branches or master branches of Kubernetes, and giving us a sense of what is how healthy our merged code right now is, and provide us signals for whether we are good to create a new release cut out of our release branches or master branches, or do we need to make any changes? Do we need to fix anything? We use this periodic jobs to get those CI signals. So these are the three ways or three types of Prow jobs that we use in the upstream project. And I'll not go into anatomy, but uh, not line by line. But if we have to see how a job is defined, um, this is how a job is defined. For example, this is an anatomy of a periodic job. Every For every single job, we have a job type identifier. So here we have this job type identifier calling it a periodic job. And we do not have to put this job type identifier on any job. It's like the start of the block. So we'll start with periodics and all the jobs that will come under it would be periodics now. Just quickly running through it, we have the name of the job and uh, different other things called pod utility, which helps us to check out whatever is coming. So if a trigger is coming from a PR, for example, we need to check out the code that is coming from that PR. All that checking out of code, we use decorate or pod utility decorations for them. Sorry. Yeah. So this is a bit about pod util. I'll skip that. This is very nicely covered in the KubeCon talk. Um, Interval is the interval. So this particular field here is telling me this job, foo job will run every 1 hour. I can also define my interval as a cron schedule. And this extra ref part is where we are telling from where that decorate true field has to get the data for from where it has to clone the information. So in this case, we are telling it, please clone the repo from org. For example, I could say org is Kubernetes and repo is Kubernetes. So and base ref is main. So we are telling it to clone the all whatever is there in Kubernetes main branch, have that available in a pod, which will be created using whatever we are going to specify in the spec section. So the spec will contain a container image, um, whatever is going to be there inside that container, the container created out of that container image, all that information is going to be defined in the spec section. It's very much similar to a Kubernetes pod spec. And all these above fields are just extra bits, whatever we defined as part of Prow job definition. So that was periodics job. Similarly, we have post summits, just giving that job type identifier. They are defined a bit different. Here we do not give that extra refs here, rather we just club all our jobs for a certain repo under another identifier as org repo and same name. And there is a pod utility spec section and different other fields. So not going to go into that. Um, After this, I think let me. I have a number 74. Okay, so
Can we just?
once,
I just need to appreciate that this is a really good slide.
yeah, we also liked it. I presented this talk with one of my co-speakers, Mario Jason Braganza, and he is the one to be credited for all this beautiful, colorful slides.
Oh my goodness. Okay. Okay.
Yeah,
Sorry. Keep going. Keep going. I'm
yeah.
an adult.
Um,
I can be an adult.
we all love this. So we just discussed about what Prow jobs are and what are the different type of Prow jobs, and a bit of anatomy. And just if you want to understand more about the anatomy, the Prow documentation link that has all the information about that. But just fast forwarding it a bit, how do we consume whatever is happening inside these Prow jobs and upstream Kubernetes space? So we have two user interfaces for that. The first one is testgrid itself. Testgrid, by that I mean the testgrid.gits.io URL, and which whenever we hit that URL, it looks something like this. It's a grid-like user interface. If we see all these tiles corresponds to a dashboard group. So for example, I've highlighted one tile here called SIG contributs. That is a dashboard group for all the dashboards of CI jobs related to SIG contributs. And I think I see Red Hat here as well. So all the OpenShift jobs, I think comes there, whatever we are showing on upstream Prow. I think all those are clubbed under that Red Hat dashboard. So if I hover over on that one of the dashboard groups, for example, in this case, SIG contributs, I can see all the dashboard tabs. And if I click on that, that's the same thing that comes here. All the dashboard tabs I can see at the top as well, and in a table format down below. And each of these dashboard tabs in turn consists of jobs inside it. It is also giving me other statistics like, for example, let's say we take a dashboard. Here, SIG contributes community. It is telling me there is only one job defined under it, and by job, one Prow job defined under it, and that's a flaky right now. And it's also giving me other information about other dashboards as well. So let's click on SIG contributes community, and I can see there is one job defined under it called pull verify. Um, we are getting a lot of information from this user interface here. It's telling me the pull verify is flaky right now. And if I click on that, this is the final uh, user interface, final thing that we can get out of this grid. So what this particular uh, screenshot is showing me is the the statistics of pull verify CI job or pull verify Prow jobs uh, of its various instances running across multiple days, not just multiple days, multiple um, iterations across multiple days. So it's showing me, I think it's a old, very old screenshot. So 4/7 on 4/7, the job ran on 1759 IST 6/5, and so many times, and how many times it was green, how many times it was red, or if the job was still running, it I would see a gray one showing me that there is this job that's currently running as well. This particular screenshot or user interface gives me other information like what is the full job name. Here it's showing me um, the Prow job name is pull community verify. So wherever in the code base, if this how this Prow job is defined as, the job is defined as pull community verify. And this is a very interesting part. So it's showing me the Prow job config URL. And if I hit that URL, basically it will be taking me to the test infra repo. So git.gatest.io is the alias for github.com/Kubernetes. And it's pointing me to the GitHub repo and specifically to that part where this particular job pull verify or pull community verify is defined. So if I hit that URL, it just took me to the Kubernetes/test infra repo in one of the files called community pre-submit YAML. And I can see that the job that we were looking at is a pre-submit, and the same thing. It's here we can see a fully defined job. So I can see there is a spec section, and we are providing an image, container image called Golang here, and all it is doing is it's checking out K community, Kubernetes community, and running make verify in that container created from Golang 1.18.2. Again, it's a old thing. Um, yeah. So if I click on one of these tiles here, for example, one of these green tiles here, it will take me to another user interface. That's what we called spyglass, Prow spyglass. So that's very much specific to right now we are looking at the statistics of a job across its different run. But if we have to check what happened in a particular job run, we see there is a failing job here. What was the logs coming out of that failing job? How to troubleshoot that? We can start looking at that side of information, but just by clicking one of these tiles. So for example, I click the first tile there, and this is what I get. Here I get the very specific instance of that job run. I'm getting information like the job run instance ID, when the job started, is it passing its failed, or is it already finished. I can get the job logs from here, whatever job logs that basically whatever pod logs that were created inside that particular pod for this Prow job. I can get all access to all those logs here. I will also get other information like pod events or whatever volumes were mounted on that particular pod that ran our Prow job. Any other spec information, what was the specification for that particular pod container pod. And yeah, I can, from the spyglass as well, I can see information like what. So on test grid, we saw the information of a job run across multiple timestamps. Here we can see information what all pull requests, for example, ran triggered this job. So I can see here uh, these many. So first is all the instance IDs, and here I can see 7242, for example, one of the PRs created by somebody, 7214, all these different PRs triggered this job. And when it was started, what was the duration, what was the result. So I can see a more granular information here, like what job actually triggered this particular
I
uh,
just
pod run.
really like that the failed job in this particular screenshot is one triggered by Jeremy Rickard. One, because he has the same last name as Johnny, and every now and again I double shake.
Yeah.
And two, Jeremy's on the code of conduct committee with me. So I just it, and of course he does a bunch of other things besides the committee as well in the community. But I just like that his I just like that he owns the one failure in the
The
screenshot.
one bad, yeah.
The one bad one belongs
He
to
has
Jeremy.
another green one after that, so he redeemed.
Not
He
important.
does. He
Not
clearly fixed
important.
whatever he broke. He fixed.
Yeah. I also work with Jeremy right now with all the release team stuff. Jeremy is one of the SIG release tech leads. Um, so yeah, coming back to Prow Spyglass, we have all these tabs at the top as well, where we can see what is the actual applied YAML configuration. So we kept talking about Prow jobs as defined as YAMLs, and when a Prow job is actually applied in a cluster, in a Prow sub build cluster, what is the actual applied configuration? We can get all that information from Spyglass. Um, Here, there is a dedicated tab which directs us back to the PR or any other GitHub event that triggered that job. And we only see that in case of pre-submits, because pre-submits are the one where uh, we are talking about whenever like I am creating a new PR that will trigger something. Post submits does not necessarily comes into are not directly related to PR. For example, something is already merged. Yes, we will get information about PRs, but uh, pre-submits are very much directly related to every single PR that triggered that pre-submit run. Periodics, those are triggered on intervals, so they are not directly related to any PRs. So we will see this PR tab only in case of pre-submits. So if I click that PR here, it's pointing me back to which PR actually triggered that particular job instance. PR history. So we are familiar with this when we are working on maybe like trying to add a new feature to any new repo. We go through multiple iteration. So we actually keep refreshing our commits, or we add new commits, or we sometimes force refresh our commit. So every new commit, every refresh of a commit will actually trigger this job again. So we need to have a history of what happened when on my last old commit hash, or what happened when I refreshed my commit. So that kind of history we get from PR history tab. Here we can see uh, this particular PR 7242 had maybe is having three commits here, DC1A, 1CB, and so on. And it's showing the pull community verify Prow job run across each of those separate individual commit hashes as well. And finally, the artifacts tab. Artifacts tab is where we are collecting everything that we are seeing on this particular screen, all the build logs, all the port job, port information, all the volumes attached, all those are actually coming back from our build cluster as artifacts to us, and we use those artifacts to create this screen here for us. So we are getting information like Prow job, what is the applied configuration. We are getting information about when the job started, um, what is the port info, and all. If the job is cloning a repo, we will get all those information about uh, what happened when cloning, or what particular instance or commit or whatever uh, was used to clone the repo. All those artifacts we will get here. Different jobs create different artifacts, so this particular artifacts tab is where we can try to get access to what artifacts are generated from a particular job. And finally, we have test grid that brings us back to the same test grid window again. So I have actually downloaded this from my slide deck, so I'm missing a few uh, emojis here. But here, what I was trying to show is Spyglass and test grid are very much interconnected. So if I have to make the best use of both of these tools, that would be using them together. Maybe keep switching from test grid and keep switching from Spyglass to get a bigger picture of how my job is doing, whether it ran. So if I have to make get an idea of whether a job is flaky, I can go and use test grid, that tiled version, to just check, let's say over um, mm, 3 days, how many times the job was green, or how many times it was red. Based on that, I can get a flaky metric from there, or yeah, other information. And if I see the job failed for once in like weeks, so I can just use Spyglass and use the specific instance build logs to troubleshoot that particular failing job. um, this is where we are talking about test infra. So we looked at Prow and test grid, all those interfaces, and uh, those are also running as part of Prow infrastructure itself. Test grid actually is a different component, not very much directly related to Prow, but in upstream space we consume it with Prow. Uh, Prow Spyglass is actually deployed as part of Prow machinery itself. So all those uh, config files for whatever we just saw, all the jobs running, all the user interface sits inside a repo called test infra, which is github.com/kubernetes slash test infra, or git.ks.io slash test infra, which is this repo here. And inside that, what is uh, important for us for this particular session is the only folder called config here. Config folder contains everything related to Prow and test grid. Uh, so we have a folder called Prow here. That Prow folder contains the Prow infrastructure config. So everything we saw on Prow Spyglass, or all the components that are receiving the hooks, or giving us our artifacts back from build cluster, and everything else, everything that is updating our uh, adding labels or giving us friendly prompts on all that machinery, all those components, we can find those config files from this folder Prow. And then we have two more folders here called jobs and test grid. That's where all our jobs and how we create that test grid dashboard user interface, how to define where a job will sit. Like if I have, for example, we were looking at SIG contribx pull community verified job. To specify that pull community verified job uh, showing needs to be shown under SIG contribx dashboard window. I will do all that defining or all that configuration in that test grids tab, and actually defining jobs will be happening in jobs folder. And this is very much specific to Kubernetes upstream. That's how we have organized our jobs and test grid stuff for entire Prow configuration there. So let's just explore the jobs folder very quickly. If I click on that, I see this kind of structure here. Most of these are defined as GitHub organization. So Kubernetes has multiple organization, GitHub organization that we are using to um, organize our code base, vast code base. So we have organizations named Kubernetes itself, Kubernetes SIGs, Kubernetes CSI, and so on. Um, so most this current folder structure is based on is very much corresponding to the GitHub orgs we have. And let's say we clicked on one of the org here called Kubernetes, and inside that, now whatever we see here are repos inside that Kubernetes org. So, and this is just for our sake of understanding here. This is the formatting we have used, which is config jobs and then all our orgs, and inside each org folder we have all the repos inside that where we currently have any jobs defined. So in this case, we have a repo called community, for example, here, which is inside Kubernetes org. Let's click on that, and I will be seeing the jobs that we have defined for that um, Kubernetes/community repo, which is this community pre-submit.yaml. So all the existing jobs that are defined for Kubernetes/community repo will be defined in this. We can also add new jobs here, or any other jobs that we want to define for Kubernetes community. We can create more files here as well and put them in this path. If I click on that community pre-submit, what I see is the same job I think we saw last. In last example, it's a pre-submit job, pull community verify. Uh, Quickly going into test grid, very similar to jobs. So if we go back and now go into our test grids folder, same uh, folder structure we have here also. We have our folders defined with org names, Kubernetes, KCP, etc. I see OpenShift also there.
KCP is also a project that came out of Red Hat as
Yeah,
well.
yeah.
That was one that I got to do some S3 consulting on for like a hot minute. It was pretty cool. So just warms my little heart to see things that I've worked on the screen, and
Yeah,
other people do the
yeah.
things with them, do real things with them. I should say. I don't think I actually contributed too much to that of value at the time because it was so early on in the project. But that's a cool project.
Mm-hmm.
Yeah, I learned about KCP, I think, when during KubeCon EU Valencia, uh,
Mm-hmm.
and there was a contributor summit, a whole session around KCP, and it was a room full of audience.
Yeah,
That was my first
yeah. It's.
interaction with
I think
KCP
we
folks.
officially donated it to the CNCF this year.
Oh,
Um, it's a little project that could. I swear.
okay. Just coming back here, so we have organized all our test grid stuff here in form again using the same org structure. Let's click on Kubernetes org, for example, and here I can see again we see all the repos here as folders inside our org folders. So if I take sig contributs again here, and there is a file called config.yaml, uh, that config.yaml files contain all the test grid dashboards or tabs that we have defined for Kubernetes/sig contributs repo. Will also become the home for anything new we want to add on Kubernetes/sig contributs repo. So this is how it looks here. We say dashboard group, and we give it a name here, sig contributs, and then we define what all dashboards we want under it. So this particular block actually goes back to our this test grid interface where we see that sig contributs. The sig contributs is the dashboard group, and all these tabs that we have defined here will become dashboard tabs, and then each will contain its job. Yeah. Um, I just want to go back and yeah. So for example, here we have pull community verify here. How I have to tell Prow to add this particular job inside one of the test grid dashboards. I'm doing that with one of the annotations here called test grid dashboards. I'm telling it, put this job, make this job come under sig contributs verify on test grid. So I would have discussed this more when if we had time to go into the anatomy part, but that's there also in the KubeCon talk.
Yep. Um,
Um,
was gonna say we are basically we're actually a little over the hour right now, so we don't have a super hard stop if you want to keep going. Otherwise, like this does feel like a pretty good natural like closing out space. I
Yeah,
learned a lot today.
Yeah.
thank you. I just have one bit, which is very quick, and I
Okay.
think that would be a good stop. And that's I think a few slides only. So I wanted to talk about if for somebody who is just like starting with Kubernetes project and they are adding like a big code uh, for a new feature or any big change in the code base, and they need to maybe troubleshoot the failing test, for example, if they have created a PR and now they see there are red pre-submit tests and they don't know what to do about them, and they want to check how these jobs are defined, whatever that job which is failing, how to check what is the definition of that job. This is a good way to do about it, but we just discuss if somebody is aware of test infra, they can navigate through that jobs and uh, org and repos format. But if they're not aware of that, the best and easiest way, and I think even as of date, I also use this is code search. So we have a tool called Hound, which is mapped to cs.kts.io. And this is just a code search tool we have for all the repos we have under Kubernetes project, all the um, not just Kubernetes org, Kubernetes SIGs and all other sub projects we have. So if I have to just find out where pull community verify, for example, is defined, I will just come here and put that string in this code search, and it will give me all the places where this is defined, and I can make out from different results here what is really intended for me. So just wanted to pass that as well. That structure is good if we are trying to define structure of going from test infra config jobs or config test grid is good if we are trying to add a new job, and if we want to know where what is the right place to add any new job, that would be the way. But if we are just trying to look for whatever is already defined, I think a code search is the easiest and most quicker way to do that. Just use cs.kts.io and put the name of the job here, and it will give you different results for wherever that particular string is coming in the different code bases. Yeah, with that, I think I'll stop here. If you want to understand how to add a new job, and if you want to test it before adding it, all that bit of information is also covered in that KubeCon talk. So if you are interested in that, maybe you can follow the last part. There are a few examples of where we have done a deep dive into taking a pre-submit or a post-submit job and dissecting it line by line on what each line is doing, or how that container for a Prow job is formed, what goes inside that Prow job container, all that information. We have discussed them with a few examples in the KubeCon docs. So that's also there. And thank you. With that, I'll stop sharing and come back to the screen.
Wow. Well, again, thank you. Because I learned a lot today about all the things. It's definitely one thing to have a what do you say? I think I've had a conceptual understanding of Prow to now, and to kind of get this a little bit more deeper understanding. I found it very useful. My brain's also very tired, so I'm having trouble with the whole enumerating on all the reasons I found it useful. But I found it useful, and then the recording will live on forever on the Red Hat YouTube channel, so I can proceed to repeatedly find it useful in the future when I like, what did Priyanka say? I would just go check or I'll send you a Slack message because I'm lazy. That's always my other
Um,
option. And speaking of which, like, you are a very accessible human, right? You are, you easily found in the Kubernetes Slack. That's where you and I still keep in touch most of the time. And you will be at KubeCon. So if
yeah.
our viewers are at KubeCon and you see Priyanka, say hi. If our viewers are at KubeCon and you see me, I guess you can also say hi, but like I think I'm old news at this point. You don't really care that much. But I will have some of the, I'll save you one, Priyanka. I will have some of the last remaining pieces of GitOps Guide to the Galaxy swag. I will be bringing a bag of it and I will be carrying it around. And the only way that you can get this swag is by asking me. Not even Johnny has this swag. I am the only place to get it, the exclusive. I don't know. Are they going to make us more swag ever? I have no idea. I bet I can get them to make us more stickers.
That'd be awesome. I think I'll have to look. I think I have a couple. Like I know I have some Ask OpenShift admin, but I'm not sure about GitOps Guide.
But I think they sent you one, like, because they sent me an Ask an OpenShift admin shirt and an Ask an OpenShift admin mug when they did, like, but that was like for my personal use.
Mm-hmm.
And then I received some like grand, here's the shipping boxes full of your swag to hand out when you go places. Enjoy.
Yeah. Yeah, I got that too. I got that. I thought that I have to go back and look because I know I got a bunch of Asking OpenShift admin stickers and mugs and like not a lot of t-shirts, but you know, a decent amount.
Yeah, I got the stickers here.
Oh yeah.
They did 2 runs of stickers for me. They gave me small stickers and then I got the big stickers. Here we go. It's like literally sitting on my desk because I'm a hot mess. I got the small sticker, which I only have a couple of these left. So I'll have this stuff on me. So I'll have stickers. I'll bring some of the coffee mugs because if I don't bring them to these conferences, like otherwise they're getting handed out as holiday gifts. Like
yeah. All, my wife's friends are like, "What is this coffee cup?" I'm like, "It's the greatest, live stream you'll ever see. Just check it out."
Literally,
no,
don't put the coffee mug through the dishwasher. Learned that the hard way.
Ooh,
Not
yeah,
dishwasher.
or the microwave.
It's metal, so that one was a little bit more obvious. Like that one, I didn't need telling. Oh man, bring me an Ask an OpenShift admin coffee mug though, so that I can replace the one that went through the dishwasher.
All right, I'll hook you up.
Yeah. Okay. I like that we're just like arranging our swag situation.
That's right.
It's okay. My best water cup is actually a Suse cup, but don't tell anybody. Red Hat hasn't given me as anywhere near as nice a water cup as this one, or any cups actually. Red Hat has given me 0 cups. So I was at a conference in February that was here in Oakland, and somebody snuck me the good swag.
Yeah, that's awesome. Yeah, like Salesforce.
Even I don't have that.
Mm-hmm.
See, that's the thing. Like our swag is okay, but like Salesforce, their stuff is legit. Like they were getting like Yeti coolers and stuff like that. I'm like, man, that's the real deal right there.
The swag game is real. I got a really, that's the thing I'm looking forward to is like, what great swag can I get? I'm hoping I'll get one of the Snick dogs this time. Last time I did not succeed in getting the Snick dog. I want that. Oh no, my headphone died. You guys are gonna get echoed now.
Yeah, I was at the open source summit and like I can't remember the company, but they had dog toys and they were like Star Wars dog toys. And my puppy was a monster. She's still a monster, but she was like a baby monster at the time. And so I was like, oh, she's gonna love this. Got it home like within 10 minutes, like just cotton everywhere. It's completely destroyed.
You know what I can't keep to save my life? I can't keep Argo plushies. My children keep aggressively stealing my Argo plushies. And it's like, you already each have one.
Yeah.
Why do you keep taking them?
Because they need yours.
What it is so Intuit gave me, they were so sweet. One of the people at the booth, they gave me 2 so that I would take them to the kids. And it's like the ones like with like the normal red shirt.
Mm-hmm.
But I have the special edition Hawaiian shirt Argo plush. And that's the one they keep stealing. So I need them to do another interesting shirt so that I have a hope of keeping my own Argo plushie.
Yeah. That would be awesome.
It would be awesome.
Okay, awesome.
Well, we're super overtime. We are so like, it's late. We're tired. It's past my bedtime. I go to bed early because I get up early. It's 9:15. Like I'm like not even an intelligent human levels of tired at this point. It's even later for Johnny. So we're gonna get to bed. But Priyanka, it's your morning over there in India. We forgot to mention where you joined us from, right? You're over in India. That's the whole reason we did this time slot.
Yeah, I also should have included that in my introduction, but a later introduction. I'm from India. Yeah, and
Totally.
it's almost 10 for me now, so
Yeah,
I'll
10
go
in the
start my
morning.
day.
Yeah. So have an awesome day. Thank you so much for coming on and talking to us about these things. Again, like I said, you're basically were my cheat sheet for things I have to do in my day job, which like I think this is my
Thank
day
you
job.
for giving me the opportunity, and well, again, Hill is my mentor from very long. I think from the start of my career now, and Craig is in the chat. He has been there for me again from the beginning of my career. So thank you for having me here, and thank you for having me this having give providing this opportunity to talk to you all again and being part of this small red hat group again.
Yeah.
That is
Okay. Well,
always nice.
we'll see you in a few weeks here. We will not be streaming in 2 weeks because I'll be at KubeCon. So end of November, I forget the day. End of November is the next stream, and then it'll get really choppy through the end of the year because it's the end of the year and we go on
Mhm.
vacation and stuff. So, but we'll see you all in roughly-ish a month. Or people watching the recording, we'll see. We probably will actually see you live as opposed to this, different audience. But we'll try to do more late shows eventually because this was actually really fun. Johnny's going to run the outro, but first I'm going to remind everybody to choose your technical debt wisely, and I'll see you in a few weeks. Cheers.